Now, good morning. So I want to solve a problem using Lambert W function. Yes. And what does Lambert W function says? Lambert W function says that the W of x e exponent x is equals to x. Yes, I'm assuming f to be a function of x. You understand? I'm assuming I have a function containing x. Yours can be a function containing y. Yours can be a function containing a. Yours could be a function containing w. You understand now? So assuming x is a function of x, then Lambert, this holds for Lambert w. So shall we apply this function here? Now take note and see I'm going to solve the problem. Now the first thing is you actually bring the x to the other side and we end up having 3 raised power x is equals to 30 minus x when you bring the x to the other side. And do you know that this same thing here is the same thing as having 30 minus x is equals to 3 raised power x? Yes. The next thing you are going to do is divide both sides by 3 raised to the power of x. Dividing both sides by 3 raised power x gives you, and you have 30 minus x all over 3 raised power x is equals to 1. Now take note of this particular part here. Do you know that this thing is the same thing as 30 minus x over 1 times 3 raised to the power of x? Yes, it's the same thing. And do you know that you can write this one as 3 raised to the power of negative x? That's the inverse of 3 exponent x. Now if I apply it here, I will end up having 30 minus x times 3 raised to the power of negative x is equals to 1. Yes. Now, knowing this now fully, what next can I do with this problem here? Now, remember I'm working towards a function. Now, let me multiply both sides by 3 exponent 30. Multiplying both sides by 3 exponent 30 gives me 30 minus x times 3 raised to the power of minus x times 3 exponent 30 is equals to 1 times 3 exponent 30. Are you with me now? So the next thing is 30 minus x. Applying the multiplication law of indices here, you have 3a raised power x times a raised power y becomes a raised power x plus y. Applying it here, you end up having times 3 exponent 30 minus x is equals to 3 raised power 30. So what next can we do now? Look at the problem very well. I want to show you something. I want to remind you of something about natural logarithms. Do you know that the exponential of the natural log of 3 is equals to 3? Yes, that's exponential of natural log of 3 is equals to 3. Shall we show this? You can actually show this yourself. Let's assume y is equals to e ln of 3, for example. You understand now? If you then take the natural log of both sides, that's the ln of y is equals to the ln of e ln of raised power ln of 3. Now remember, power law. You understand now? If you apply the power law here, you have the ln of e times the ln of 3. Yes, or you can rather say the ln of 3 times the ln of e. Yes, it's the same thing. Now having this, you have ln of y is equals to, now ln of 3. Remember that the ln of e is the same thing as having log of e base e, which is 1. So that means this is multiplied by 1, which gives you the ln of y is equals to ln of 3. That is y is equals to 3 if you eliminate both ln. So automatically that means this is equivalent to this. So by so continuing my solution, I end up having, that means I can replace this 3 here with exponential of natural logarithm of 3. Yes, that means this 3 you are having here is the same thing as this. Remember, it has an exponent of there's an exponent of 30 minus x here is equals to 3 raised to the power of 30. Are you with me now? Now, in order to make this function the same thing, remember this one is a power here. This is acting as a power 30 minus x. Now, if I decide to apply the power law again, I will have 30 minus x, open brackets, my e, or rather e, bring this one here, that's power law, you have 30 minus x, the ln of 3, which is equals to 3 raised to the power of 30. Now, in order to make this thing here the same thing, in order to make both sides the same thing, let me multiply both sides by ln of 3. Multiplying both sides by ln of 3 gives me multiplied by ln of 3 times exponential of 30 minus x, the ln of 3 is equals to 3 raised power 30 times ln of 3. And so, looking at this problem now, let's proceed. So, having multiplied both sides by ln of 3, I'm working towards the function, remember. So, we are going to then have, remember this was where we stopped. Now, looking at this part here, we are going to then have, look at this problem here. Now, if I then apply the rule, the function rather, the Lambert W function, that says W, or let me take the W of both sides, we have 30 minus x, the ln of 3 times exponential of 30 minus x, the ln of 3, is equals to the W of 3 raised to the power of 30, the ln of 3. Yes, remember I'm working towards a function. That is W of x e of x is equals to x. That means we want to actually obtain, remember, we assume, let me use y instead now, so you don't get things wrong. So that means the whole of 30 minus x ln 3 is my y. So I want to obtain something like this. So that means if I'm able to obtain something like this, automatically if you look at this very part here, you will realize that I have 30 minus x ln y. So I can assume this whole part is my y, this whole part is my y, which is meant to give me y in return. So that means I'll probably be having the Lambert function of this to give me 30 minus x, the ln of 3, is equals to, if you apply it in that part too, you are going to have W of, remember I can write 3 raised power 30 as 3 raised power 3 times 3 raised power 27, the ln of 3. I have my reason for doing that. So, and this one becomes the W of 3 raised power 3, the ln of 3 times 3 raised power 27. And this one is the same thing as W of 27, the ln of 3 times, remember 3 was exponential of ln 3, you understand? All raised to the power of what? 27. Are you with me now? And so this is going to become W of 27 ln of 3. This was my aim. I'm trying to obtain something in the form of this here. So dot E. Now remember power law. Bring down the 27. You have 27 ln 3. You understand now? That means we can have 30 minus x, the ln of 3, to be equal to that. Remember, if you apply the same thing here, this is going to give you 27 ln 3. So that means we are having 30 minus x ln of 3, 30 minus x ln of 3, 30 minus x ln of 3. So remember, if you divide both sides by ln of 3, you end up having, dividing both sides by ln of 3, you have 30 minus x is equals to 27. And so therefore we have minus x is equals to 27 minus 30, so that my minus x is minus 3. Dividing both sides by negative, you have x to be 3. So this is our required solution. You understand? This is our required values of x. So don't forget to like, share, and subscribe. Thank you. Yes,